Now we're starting an application of integration, that is area under the curve. So for example, if we have this curve, for example it's 5 minus x square, 5x minus x square, and we need to find this area. So what we'll do is we'll integrate this curve. First what we'll do is we'll equate this with 0 and find the two x-intercepts. This x-intercept will come as 5 and this is 0. So we'll integrate this curve from 5 till 0. This will give us this area, the green shaded area. However, if we have this curve and we need to find this area. So in this case what we'll do is we'll first find the x-intercepts by equating this with 0. This will be 3, this will be 0, and we'll integrate the curve from 3 till 0, but because it's below the x-axis we'll put a minus sign before it. Now this was when we had to find the area bounded by the curve and the x-axis. What if we have to find the area bounded by the curve and the y-axis? This equation, the equation of this line is this curve would be so if we have to find this area that is bounded by the curve and y-axis, we need to have the equation of the curve in terms of y. Now this will come as 4 and this is 0. We'll integrate the curve from 4 till 0 with respect to y to get the value of the area. Now if similarly we had to find this area and the curve was then we would integrate this from 4 till 0 with respect to y, but we would put a minus sign over here. Usually we will have to find the area bounded by the curve and the x-axis, that is we'll have the equation in terms of x, and what the kind of questions that we get are that we might have a triangle like this and a curve like this, and we might have to find this area. So for that what we would do, we would find the area, we would find the green shaded area, subtract the area of the triangle from it to get this region. Now we'll do some questions to understand it better. This is the first part of the first question. First we have to find we have to differentiate this equation. So dy over dx equals to, we have to apply the product rule, x into the differential of this, that will be minus e to the power minus x, plus we'll copy down this, and the differential of this will be 1 upon, no that's it, and we'll be adding this here. So this is equals to minus x e to the power minus x plus e to the power minus x. This is the differential. Now you have to show that integral of this is equals to, so for that what we'll do is we'll first write integral of this thing equals to the equation that we had in the question. Now this can be written as now we'll integrate this. We leave this as it is and we'll integrate the second part. This will become e to the power minus x upon the coefficient of x, that is minus 1. This can be written as minus e to the power minus x is equals to x e to the power minus x. Now this is shifted on that side, so it is added over there. When this minus sign is shifted on that side, this becomes minus and then we add c. The next part of that question has this graph and it's saying find the area of the shaded region. Now over here, this red line is the tangent and this is the curve, that is x e to the power minus x. Now to find the area of this shaded region, that is bounded by the y-axis, the tangent and the curve, we have to form a trapezium over here. This is a trapezium. Now to find the area, first we find the area of the trapezium and then subtract the area under the curve to find this area. Now to find the area of trapezium, we'll need the coordinate, the y coordinate of this point to find the length of this side. So for that we'll have to find the equation of the tangent, substitute the value of x as 0 and then find the value of y. So for the tangent, we'll first differentiate this. Differentiating this, now we'll substitute the value of x as 2 to find the gradient. The gradient is coming as minus 0.135, or we can keep it in terms of e, minus 2 e to the power minus 2 plus e to the power minus 2, that is minus e to the power minus 2. So this is the gradient. Now for the equation of tangent, we have the formula y minus y1 equals to dy over dx x minus x1. Now y1 is 2 upon e square, so y minus 2 upon e square equals to minus e to the power minus 2, that is dy over dx, and x1 is 2. Now to find the y coordinate of this point, we'll substitute x as 0 because over here x is 0. So 0 minus 2 will become minus 2. Simplifying this, so y is coming equals to 0.54. So this point is 0, 0.54. Now we'll have to find the area of the trapezium and subtract the area under the curve. For trapezium, we have the formula half into height. This is the height, that is 2, into sum of parallel sides. So sum will be 0.54 plus 2 upon e square. So 0.54 plus 2 upon e square is equals to 0.812 minus integral of x e to the power minus x from this point is 2 as given over here, and this is 0, so from 2 till 0. So we know that the integral of this is this, so now we'll simplify this. So 2 and 2 get cancelled out. 0.812 minus 2 e to the power minus 2 minus. Now when we substitute 0 in place of x, 0 into e will be 0. So we leave that out, and then over here minus e to the power minus 0, that means 0. E to the power 0 means 1. Now minus and minus becomes plus, so plus 1. And 0.812 minus 3 e to the power minus 2 minus 1. Now putting this in the calculator, so we're getting the answer 0.218 units squared. Now in this question we have the curve y is equals to 8 plus e to the power minus x upon 3 in red, and the normal to that curve at the point P is in green. Now that normal cuts the x-axis at Q, so we have to find the coordinates of Q. Now first we'll have to find the coordinates of P. At P, x is 0, and y, for y we'll have to substitute 0 over here, so 8 plus e to the power minus 0 upon 3, this power becomes 0, e to the power 0 is 1, this is equals to 9, so the coordinates are 0, 9. Now for the coordinate of Q, first we'll have to find the equation of the normal. For that we'll find dy over dx. This will be e to the power minus x upon 3 multiplied by the differential of this power, that will be minus 1 upon 3. Now when we substitute the value of x in this, that is 0, so we get e to the power 0 into minus 1 upon 3. E to the power 0 is 1, so the gradient is minus 1 upon 3. Now for the equation of the normal, we have the formula, we have the equation y minus y1 equals to minus 1 upon dy over dx, x minus x1. y1 we found as 9, dy over dx is minus 1 upon 3, and x is 0, x1 is 0. Now 3 shifted over there, this will become 3, so y equals to 3x plus 9. Now q is the x-intercept, at the x-intercept y is 0, so 3x plus 9 equals to 0, therefore 3x equals to minus 9 and x equals to minus 3. So the coordinates of q are minus 3, 0. Now the next question says, as RQ is parallel to the y-axis, OQRS is a rectangle. This line is RQ and it is parallel to the y-axis, that is why this is a rectangle. And we have to find the shaded area. And for that what we'll do is, we'll first find the area of the whole rectangle and then subtract the area under the curve from it. So for the area of the rectangle we need the length, and the width we have as 3 because Q is minus 3. So for the length, we'll substitute the value of minus 3 into the curve to find the y coordinate of this point, of point R. So that will be the length of the rectangle. So for that, y is equals to 8 plus e to the power minus 3 upon 3. These get cancelled. This becomes minus 1 into minus 1 plus 1. So 8 plus E is the length. Now for the area, we'll have 8 plus E into 3, that is the width. So 24 plus 3E. This is the area of the rectangle. Now for the area under the curve, we'll integrate this curve from 0 till minus 3. So integrating 8 plus e to the power minus x upon 3 with respect to x from 0 till minus 3. So integral of this will be 8x plus e to the power minus x upon 3 divided by the coefficient of x, that is minus 1 upon 3. This is from 0 till minus 1. Now substituting the values, 0 substitute over here. First we'll simplify this in part. So 8x. Now minus sign goes over here and 3 is shifted to the numerator. This is from 0 till minus 1. So when 0 is substituted over here in 8x, it becomes 0. So we'll leave that and then we'll do minus 3 e to the power. When 0 is over here, this whole thing becomes 0, so e to the power 0 minus 1 over here becomes minus 3 in fact, because this point is minus 3. So minus 3 into 8 is minus 24 minus 3 e to the power. Now these 3 get cancelled, this whole thing becomes 1. Now this was the area of the rectangle, and now simplifying this becomes 1, so minus 3 plus 24 plus 3e, this is equals to 21 plus 3e. Now we have to subtract this from area of the rectangle, so 24 plus 3e minus 21 plus 3e, 24 plus 3e minus 21 minus 3e, 3e and 3 get cancelled, 24 minus 21 is 3 square units. That's the final answer. So in this question we have a curve y is equals to sine half x and a tangent to the curve, that is the line in red, at the point P, and this tangent cuts the x-axis at the point Q. You have to find the coordinates of Q. Now for this, first we'll have to find the equation of the tangent. So first we'll find dy over dx. Sine half x has to be differentiated. Sine becomes cos, and differentiating the angle we'll get half, so half cos half x. Now substituting the value of x into this, that is 3 upon 2 pi. So half cos this gives us minus under root 2 upon 4. Now for the equation of the tangent, we have y minus y1 is equals to dy over dx into x minus x1. y1 is under root 2 upon 2 equals to dy over dx, and x1 is 3 upon 2 pi. Now to find the coordinates of Q, y will be 0, so we'll have 0 over here, and now shifting this on that side, in fact these will get cancelled, 2 1s are 2 2s are, so 2 equals to x minus 3 upon 2 pi, x equals to 2 plus 3 upon 2 pi. This is equals to 4 plus 3 pi over 2. So the coordinates of Q are, we'll simplify this, 6.71, 0. because this is equals to 6.71. Now the second part says find the shaded area. Now for the shaded area, what we'll do is that we'll form a triangle that is over here. Now the height of this triangle is under root 2 upon 2, while the base is 6.71 minus 3 upon 2 pi, because this point is 6.71 and this point is 3 upon 2 pi, so that is the base is the difference of these two values. First we'll find the area of this triangle, and we'll find the area under the curve, subtract that from the area of the triangle to find the shaded area. For the area of the triangle, half into height is under root 2 upon 2, that is this point, into the base is 6.71 minus 3 upon 2 pi. This is coming equals to, if we take the value of 6.71 as 4 plus 3 pi upon 2 minus 3 upon 2 pi, the answer will come 2. So 2 and 2 are cancelled. The area is under root 2 upon 2 of the triangle. Now for the area under the curve, we have to integrate the curve, that is sine half x with respect to x from this point to this. Now for this point, what we'll do is, to find this point, we'll equate, first let's make some space over here. So the area of the rectangle is under root 2 upon 2 angle. Now to find the x coordinate of this point where the curve meets the x-axis, we'll equate sine half x with 0, because over here y is 0. Now sine inverse sine inverse 0 is equals to 0, so half x equals to 0. Like this is alpha equals to 0. Now the value of x at this point cannot be 0 because 0 is over here. So we'll take the next quadrant, the second quadrant. That is, in the second quadrant, half x equals to pi minus alpha. Alpha is 0. So the value of x over here will be 2. So we'll integrate this curve from 2 pi till 3 upon 2 pi. Integration of sine half x will give us minus cos half x upon half from 2 pi till 3 upon 2 pi. So 2 will be shifted over there, minus 2 cos half 2 pi plus, because minus and minus is plus, or in fact minus cos minus 2 cos half 3 upon 2 pi. So putting this in the calculator, minus and minus becomes plus. This is coming equals to 2 minus under root 2. This is the area under the curve. Now for the shaded area, we'll subtract the area under the curve from the area of the triangle. Area of the triangle is under root 2 upon 2 minus 2 minus under root 2. Putting this in the calculator. This is coming equals to 0.121 squared units. In the first part of this question, we say that the tangent to the curve y is equals to 5e to the power x plus 3e to the power minus x at the point with x is equals to ln 3 upon 5 meets the x-axis at P. Find the coordinates of P. Now for this, we'll have to first find the equation of the tangent. For that, we have to find the value of y when x is ln 3 upon 5. So for that, 5e to the power ln 3 upon 5 plus 3e to the power minus ln 3 over 5. So y is equals to y is coming equals to 8. Now to find the equation of the tangent, we'll need dy over dx. So for that, 5e to the power x into 1 plus 3e to the power minus x into minus 1. Substituting x over here, x is ln 3 upon 5, so 5e to the power ln 3 over 5 minus 3e to the power minus ln 3 over 5. So dy over dx is coming equals to minus 2. Now for the equation of the tangent, y minus 8 equals to minus 2 x minus ln 3 over 5. Now the tangent crosses the x-axis at P. That means that y is 0. So we'll remove y from here. 2 1s are, 2 4s are. So x is equals to 4 plus ln 3 over 5. Coordinates of P are 3.49, 0. Now in this question we haven't been given the graph. They're saying that the area enclosed by the curve, the y-axis and the positive x-axis and the line x is equals to a is 12 units square. Find a. This means that if, for example, this is the curve, this is the line x is equals to a, this is the y-axis, this is the x-axis. So the area enclosed by the curve, the y-axis, the positive x-axis and the line x is equals to a means this area is 12 units square, and we have to find the value of a. So for this, what we'll do is that from this diagram, on the rough sketch, we can see that integrating the curve with respect to x from a till 0 gave us that area. So integrating the curve with respect to x from a till 0 is equals to 12. Now we have to find the value of a. Integrating this, 5e to the power x remains the same as it is divided by 1 plus 3e to the power minus x upon minus 1. Minus 1 shifted over there becomes minus from a till 0 equals to 12. So now 5e to the power a minus 3e to the power minus a minus 5e to the power 0 minus 3e to the power 0 equals to 12. So 5e to the power a minus 3e to the power minus a. This becomes 5 minus 3, that is 2. So minus 2 minus 12 equals to 0. Now 5 e to the power a minus 3e to the power minus a minus 14 equals to 0. Now we have this equation. We'll use this equation to find the value of a. For that, what we'll do is we'll take a substitution. We'll take, suppose b equals to e to the power a. So therefore 5e to the power a will become 5b minus 3e to the power minus a. This can be written as 3 upon e to the power a. So this is 3 upon b minus 14 equals to 0. Now we'll shift this on that side. 5b minus 14 equals to 3 upon b. 5b square minus 14b minus 3 equals to 0. So 5b square, 5 3 is 15, plus b minus 15b minus 3 equals to 0. We broke the middle term, simplified. Now taking b common, 5b plus 1 minus 3, 5b plus 1 equals to 0. So over here b is either equals to minus 1 over 5 or b is equals to 3. Now b was e to the power a. So e to the power a is equals to minus 1 over 5 or e to the power a equals to 3. Now to find a, we'll put ln on both sides. Ln e to the power a can also be written as a ln e equals to minus 1 over 5 minus equals to ln minus 1 over 5, or a ln e equals to ln 3. Now ln log with a minus sign, with a negative multiple is not possible, so this is not possible. While over here ln e is equals to 1, so a equals to ln 3, or you can simplify it to a equals to 1.10.